Hi guys, happy Monday. Welcome back. I hope you had a great weekend. Today's focus is going to be multiplying with decimals, and we're really going to stick a focus on multiplying, solving, but also knowing what the model would look like too, right? You're not always going to draw out your model. Sometimes it's a little tedious, sometimes a little unnecessary if you don't maybe need to. But you still need to know what the model would look like based off the problem. So get out your journal. Stop focusing. This camera's losing it. Get out your journal, title the page, or just find a new page, and we're going to title it Modeling and Solving with Decimals. Oh my goodness, stop. I don't know why it's trying to, what's causing it to do that? Okay, hopefully it stops doing that. Okay, no. Are you done? Are you done, document camera? Okay. So get your page titled this. And we're going to do 3 different problems together. We're going to do a decimal times a whole, a decimal times another decimal, and then a unique problem where it's a decimal under 1 times another decimal under 1. So go ahead and split your page into 3 parts. Let me zoom out a little bit. Go ahead and split your page into 3 parts. Oh, it doesn't have to be perfect, obviously. Split your page into 3 parts because we're going to do, again, a decimal times a whole, a decimal times another decimal, and then also 2 decimals less than a whole. Because these are quite unique problems that they all are solved with a little bit different thinking. And their models look different, and how we solve them looks a little bit different. I mean, we're going to use the standard algorithm to solve our problems with decimals, the standard algorithm of multiplication. But yeah, so let's set up our 3 problems, or we can just start by focusing on one. We'll start on focusing decimal times a whole. So in decimal times a whole, we're going to do 24.8 times 9. So we could sit here and draw a model of this. We could draw a model. Now, what makes more sense? 24.8 groups of 9? Or if we flipped it around and said 9 groups of 24.8? Which one makes more sense to you? Yeah, 9 groups of 24.8. So we know if I did make a model, it would be like drawing 9 circles and putting 24.8 inside each, right? But I don't necessarily need to do that. One, takes a lot of time, it's kind of tedious. So instead we can write what our model would look like. 9 groups of 24.8. That is what our model would look like. Stop focusing. Okay. If I keep a hand in the shot, maybe it'll stop. 9 groups of 24.8. Now, my kids know this, and I've drilled it hopefully into their heads enough. When you're working with decimals, the first thing you have to do before you even solve the problem is estimate, because that estimation is going to help you place your decimal point. I don't want to hear about the tricks of, look, count how many spaces. Nope. You're going to estimate. So let's go ahead and knock out our estimation. Estimations are supposed to be easy. They're supposed to be something you can do in your head. Like, it's not supposed to make you just do extra work. Estimation should be something you can do in like 10 seconds or less. Look at 24.8. What would you round it to? What whole number? 24.8? Yeah, I'd probably round it to 25. It's really close to 25. I could leave 9 the same, but you know what 9's really close to? What do you think? 10. 10's a pretty, oh my gosh, focus. 10's a pretty easy number to estimate with. So 25 times 10 is our estimate. So, what is 25 times 10? Yeah, that's a no-brainer. 250. Anything times 10, right? I mean, just add a 0 to the end. We've known that. So now we have our estimate, 250. So now we go ahead and actually solve. We take the decimal with more digits and we put it on top, 24.8, and we put the one with the smaller digit on bottom, the 9, and then we just use standard algorithm. At this point, if you want to pause the video, do it yourself, and then just check with me after you're done. I totally welcome that. I think that's an awesome idea. If you want to do it with me, like along with me at the same time, that's totally fine too. 9 times 8, 72. Carry the 7, drop the 2. 9 times 4 is 36 plus 7. Y'all, I'm not afraid to bust out some fingers. So 9 times 4 is 36 plus 7. Starting at 36, then it's 37, 38, 39, 40, 41, 42, 43. See that? 43. So drop the 3, carry the 4, and I'm going to mark out my 7 because I already used it. 9 times 2 is 18 plus 4, 19, 20, 21, 22. Don't be afraid to count with your fingers. They're there for a reason. So I got 2,232. Obviously not my right answer. That's way too big. So go back and look at your estimate. Your estimate's 250. Where could I place that decimal point to get it close to 250? Here, 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 or here. Or even here, but no. Yeah, I would go right here to make 223. It's not like right close to 250, but it's pretty close. It's closer than any of the other options. So that's how we solve a decimal times a whole. Now let's do a decimal times a decimal. We're going to do 6.5 times 1.23. 6 5/10 times 1 23/100. So come on, camera, you can do it. Okay. So our model, what makes more sense to you? 6, well, and we know this is a half, right? 6 1/2 groups of 1.23 or 1.23 groups of 6 1/2. Yeah, I'd probably say 6 1/2 groups of 1.23 because, and let's write model, 6 1/2 groups of 1.23. Because even though that might sound kind of weird, the model really wouldn't be that difficult. Think about it. You would need 6 groups, 6 whole groups, 1, 2, 3, 4, 5, 6, and then you would need like a half a group. And there's how much in each of these? Yeah, 1.23, 1.23, 1.23, 1.23, yada, yada, yada. You get the drill. It's the same number 6 times. However, this one wouldn't have 1.23 in it. It would have what? Half of 1.23. So we can leave this model alone for a minute, because I know you're thinking, well, I don't know what half of 1.23 is. So I get it. We'll leave that blank for just a second. We can come back and fill it out, or we can just leave it. I mean, you get the idea. Because our next thing is to do our estimate. What would you round 6.5 up to? Would you round it up to 7 or down to 6? Well, yeah, because the 0.5, I'm thinking round up to 7, right? So 7 times 1 and 23/100ths, what would you round that to? Probably just 1 whole, right? Times 1 whole. What is 7 times 1? 7. Look at that estimate. It's just 7. That's it. So our estimation for our product, for our answer, is just 7. So now it's time to actually solve. Now, listen here. You've been taught something that might be incorrect. You might have been told previously to this, always put the bigger number on top. Okay, well, hold on. That's not necessarily true, because look over here. 6.5 is bigger than 1 and 23/100ths, but which one has more digits? This one does. This has 3 digits, 1, 2, 3, versus this only has 2 digits. So you shouldn't put the bigger number on top. You should put the number with more digits on top. So I'm going to put the 1.23 on top underneath the 6.5. You don't need to keep decimals lined up for this. For multiplication, you do not need to put decimals lined up because, guys, you don't place the decimal until the very, very, very end. Okay? If you want to pause, solve it yourself, and then unpause to watch and check yourself, you may. We're going to go ahead and solve it. 5 times 3 is 15. 5 times 2 is 10, plus 1 is 11. Mark that one. 5 times 1 is 5, plus 1 is 6. Got the first row done. But see, this has 2 digits on bottom, so I'm not done yet. I need to put, what's the most important thing that goes here when I move to the second row? A placeholder. 6 times 3 is 18. 6 times 2 is 12, plus 1 is 13. 6 times 1, 6, plus 1 is 7. When I add these up together, see how there's no decimals in here? Don't have decimals in there, not yet, not until the very end. 5, 9, 9, 7. All right, guys, got my answer. 7,995. Or is it? Of course not. Our estimate was only 7, guys. That's way too much. That is way too much. So, where should the decimal go in this number to get it close to 7 wholes? Should it go here, 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 or here? It should go here. 7 wholes and 995 thousandths. That's a lot in the decimal place, 995 thousandths. It's really close to 8 wholes. But it's because we had a lot of decimals multiplied together, right? And we went by our estimate, and that's where it goes according to our estimate. All right, last one. Almost done. This one is that real tricky one. Because we haven't done it very much. This is when we multiply 2 decimals that are both under a whole. So, for example, the numbers we're going to use today are 5/10 times 7/10. Now, up until now, remember when we kept saying groups of, groups of, groups of? See, that doesn't really make sense here because 0.5 groups of 0.7? That sounds bad. It doesn't sound good. So remember, when you encounter something like that, you probably need to change the groups of to simply the word of. 5/10 of 7/10. And what is this again? That's not just 5/10. What else do we call that number? We call it a half. Half of 7/10. Half of 7/10. Half of 7/10. Now, that sounds like something I could solve. And the model for this is that really super fun coordinate grid. I know you're cheering. I can't hear you, but you're so excited to draw not a coordinate grid, sorry, a hundredths grid. So, I know it's going to look like a little bit of hot garbage, guys, but just bear with me. We're going to make a hundredths grids on our own. So you need 9 lines going vertically and 9 lines going horizontally to make a hundredths grid. 1, 2, 3, 4, 5, 6, 7, 8, 9. Hey, not half bad. Let's see if I can keep it up for the horizontal ones. 1, 2, 3, 4, 5, 6, 7, 8, 9. Not half bad. I'm actually impressed with myself. Alright, so finish your hundredths grid. Pause the video if you need to. Finish your hundredths grid. And then remember, if you've got 2 colors lying around the house, go grab them. They can be highlighters, they can be crayons, I mean whatever. Because you need 2 dedicated colors. Choosing pink was apparently a horrible idea. That pink did not settle well with that 0.5. So I see 0.5 and I see 0.7. And for this model, what we do is that we model the 0.5 first, and so we can model that horizontally or vertically, it doesn't really matter. So 0.5, remember that's a half. So if I color in 5/10 of this grid, well remember each one of these is a tenth, so I'll do vertical. So So here is what 5/10 looks like on my grid. Everybody with me so far? That's what 5/10, right? It's half of the grid. And now your 7/10, you're not going to go vertical. Now that you've already gone vertical with one of the numbers, you're going to go horizontal with the other number. So if I wanted to color in 7/10 of this grid, wait for it to focus, come back to me. Come on. Oh, good Lord, come on. And there we go. I would color, oh, are you kidding me? Go slow. Don't upset it. Okay. Gonna go, oh my God. Gonna go sideways like this. I'm gonna go horizontal. And I'm gonna color in 7/10. So 7/10 is kind of almost the whole thing. I mean, so I know it's hard to see, but all of that is also colored yellow. Look at that different color I made. Do you see? It's kind of like a purple, a yellow, and a red. And that's great. I'm glad that it made a different color. It's really important because that different color is actually your answer. That different color is your answer. Count how many, either on my paper or on your paper, how many red squares are there? Where the yellow and the pink overlapped, how many red squares are there? 1, 2, 3, 4, 5. 2, 3, 4, 5, 6. So you should have counted 35 squares. 35 squares out of how many? How many squares are there total in this whole grid, guys? There's 100, right? So say that out loud. 35 out of 100. 35 hundredths. 35 hundredths. How do I write 35 hundredths? Well, 0 holes because we didn't color in any hole. And 30 5/100ths. There's your answer. That's it. That's it. The model is essential for us to use. Now, you might have got the answer way long ago just because you simply said, well, I know 5 times 7 is 35, and then I'm going to put the decimal in front. I know that you're thinking that's going to work every time. Just be careful. If you try to apply rules like that, sometimes the rule doesn't work. It's better to use what you know will work, like making a model, okay? Plus we have the knowledge that a tenth times a tenth always equals 100th. A tenth times a tenth will always equal an answer in the hundredths, okay? You can bet on it. That is true. That is always true. That's not a trick or a gimmick. A tenth times a tenth always equals 100ths. All right. That wraps it up for our notes today. You are done. Tomorrow you're going to get some practice multiplying decimals on your own. And throughout the rest of the week, you're going to be multiplying some decimals on your own. Thank you so much, and have a good rest of your day.